Assalamu alaikum wa rahmatullahi wa barakatuh. Hello my students. This lecture will be for the students of the Oil and Gas Engineering Department in the International University of Technology, Twintek. The subject talking about the petroleum geology and the geophysical exploration. We have covered 4 chapters before stopping our studying due to the coronavirus epidemic before 3 or 4 months. So we have covered in the first lectures about the geological history of petroleum. This is the start of the chapter 1, and then we move to the petroleum system and the subsurface environments. And then we're talking about the sedimentary basins and the sedimentary rocks. From the chapter 3, we have reached the source of generation of petroleum. How is that oil forms? And today we will review chapter 4, which is talking about the origin and migration, and chapter 5 and 6. So let's start with reviewing chapter 4, that we have teach some of it about the migration of petroleum. And we have studied that the generation of petroleum was by the geothermal degradation of that kerogen, which is based on a chemical process controlling by the temperatures. And according to the temperature itself, it can be that kerogen and the high pressure, the kerogen can be converted to a petroleum. So the migration of petroleum, we have studied that the migration of petroleum, it can be from its place of its origin in the source of the petroleum, which is the kitchen of that kerogen, to its place of accumulation in the reservoir rocks, which can be covered by the reservoir trap, and can be controlled by the physical and the chemical conditions of the sedimentary layers. The oil can be moved through it. So this process can be dependent on 2 main pressures, which is the hydrostatic pressures, which is the weight of that fluid column, and it's depending on that fluid, is it water or oil and gas, and also on the lithostatic pressure, which is the sum of the weight of the rock column itself, or they call it sometimes the overburden pressure of the rocks. Migration of petroleum. So there are many evidence for migration of the petroleum. One of these evidence is the oil and gas seeps, which can come to the surface, which directly from the source rocks itself or from the reservoir rocks. So this migration process can be involve the rock properties and the fluid properties. We started by the generation from this area, which is the source rock, where is the kitchen of that oil, and then moved or migrated from the source rock into carrying rocks, which can be by primary migration, and then from the carrying rocks the oil has migrated to what the reservoir rocks. And then the migration here can be by the seal rocks, which it's capping or sealing the oil and prevent it from migration. But sometimes there are some areas in the cap rocks which is permeable to that oil, so the oil seeps to the surface, and this is one types of the migration of petroleum. So there are two types of migration of petroleum. One which is the primary migration. We talk about it. It's from the source rocks to the carrier rocks, just like this. The starting process from here, and it migrates to what the carrier rocks. And the second migration, which involves the movement of that petroleum through the carrier rocks to what a permeable formation to that reservoir, or what they called it, the trap itself. So there are geographic extent of petroleum system. Any petroleum system has a geographic extent. So started by the upper border rocks, seal rocks, reservoir rocks, and the source rocks, all will be in what, in that petroleum system. If we see here in the areas which there are petroleum accumulations in these areas. So it can be also the location used for boiler history. And we have here the tab oil window, they called it, and which is just like this. And the top of that gas window, which is the start of the gas area in this chart. Then here we have the migration of that oil and the migration of that gas through this stratigraphic trap, just like this, to be just like a fault, or it can be just like in this another fault, to the anticlinal trap, which can be the oil may accumulate in this what area. This is for the migration of that oil. There is a critical moment. This moment called that point in time selected by that investigator, which that best depicts the generation, migration, accumulation of these hydrocarbons in a petroleum system. A map or cross-section drawn at this critical moment shows the geographic and the stratigraphic extent of that system. So the critical moment, which it means by this chapter, it's called that the time of that source rock maturation and its migration of petroleum into its primary trap. I have just discussed the next slide before the previous slide. So there is something called proper timing, and the proper timing, that's mean it's the timing between the accumulation of that organic material, petroleum, maturation and migration, and trap formation. So there are time and the proper time called for all these processes happened for that petroleum. So there the petroleum has a composition or chemical composition. It started with a gas which is comes from C1 to C4, the methane, ethane, and that propane. Any further composition can be in this petroleum from C5 to 15, the carbon atoms. That means that's a liquid. So there are three composition or three status of that hydrocarbons: gas, liquid, and solid. Above the C15 all the hydrocarbons can be solid. Types of hydrocarbons, we have the most important one, which is the crude oil, which is a mixture of many hydrocarbons that liquid at the surface temperature and pressure, and also are soluble in normal petroleum solvent. And we have the equation of the American Petroleum Institute, which is just the gravity, or it can be mentioned about the quality of the oil itself. This equation can be determined or calculate the API of that oil or the specific gravity of that oil. So when the API is lowered, That means the specific gravity being high. So and vice versa, which is the lower the specific gravity, the higher in the ABI. When the specific gravity is low, that's mean the oil is high ABI, and that's mean high what? High quality. Okay. All many things they call that the oil of ABI gravity, which is greater than 40 degrees, just by identify or classification of that oil, they classify it as what? Light petroleum. Okay. Also we have the asphalt type of that hydrocarbons, and this is just like to be a heavy solid form of petroleum, and also dark and what in color. Also exists at the surface temperature and pressure, and that consists of what? Heavy hydrocarbons, and also something called the bitumen, which is the asphalt itself. Natural gas, which is the fourth component, as we mentioned in the previous slide. This is the gas C1 and C1 to what? C4. This is the light natural gases types, and there are two main basic types of that natural gas: biogenic gas and thermogenic gas. The first one, which is the biogenic gas, is the natural gas formed solely as a result of bacterial activity in the early stage of the diagnosis process. This diagnosis process, which is one of the operation of the Ch4 process to conforming to the petroleum. Also we have the thermogenic gas, which is the natural gas resulted from something called the thermal alteration of Ch4. It's thermogenic, that means comes by the thermal alteration of that Ch4, which is comes by the increasing of what? The overburden pressure and that temperature. The TOC types, which is discussed in the previous lectures, and it's about the total organic carbons. So the TOC in sedimentary rocks can be divided in two types, which of these it's the bitumen type and also the Ch4 types. So the Ch4, it's called, or its definition here is an intermediate product formed during something called the diagnosis process, and is the principal source of hydrocarbon generation. Yani without Ch4 there is no petroleum. So it is a complex mixture, has a formula of C12H12ON 0.16. All of these multiplied with what? With X. Composition of that Ch4, there are three main composition, which is the called marine shale and limestone. Also we have the oil shales and the Morrigan shale, which is the non-marine one, and some of that clay. All of these comes by a triangle called by or determined by the percent of that carbon, and there is percent of hydrogen and percent of what? Oxygen. All of these components, which is close to one of the triangle. One of when the types itself just close to one of the triangles, that means its percent of that oxygen or hydrogen or carbon, it will be more high. Ch4 and bitumen. Shale rock volume, this is one of the most important things. They called it the shale rock volume. is composed of 99% clay minerals and 1% of what? Organic materials. This is the shale rocks. It can be just like to be in the rock. The mineral materials composed of 99% and only 1% of these organic materials. So these 1% of the organic materials can be classified to 90% chirogene and 10% bitumen. So the basic components of the organic matter in sediments, we have studied this in the previous lectures, which is the proteins, carbohydrates, and lipids and lignin. All of these components with time and temperature and pressure can be for something called what? The chirogene. Chirogene types and maturation process. So there are three main types of chirogene, which is the algae one chirogene الذي هو طحلبي يعني, also lipid rich chirogene, and we have the third one or called humic chirogene, which is comes from the land plants. The first type here just like to be definitions or more explanations for these types. The type 1 and 2, which is the oil brine, and the type 1 is expressed by that the chirogens are deposited typically in where in lakes, which have no contact with marine water, and lack already supply of sulfate. The type number 2, which is the chirogen, are deposited firmly in marine, جاي على طول في البحار, sitting dominated by photosynthetic organism. The type number 3, which is the chirogen form in swamps and coastal plains. Here the type 3 as classified is a gas prone, and the type number 4, it's what? Inert carbon. And here is just a picture to classify the chirogene types. It's just like the type 1 comes from this area. Also we have the type number 2 can be formed, some of it in marine settings. It's like to be mixed with that marine oil and gas. Also we have the number 3 called woody chirogene, or they called it sometimes coaly, good gas, and تعتبر هنا good gas source. Number 3. Rate of maturation، والذي بيقول لك نسبة النضوج نفسها كيف كانت بالنسبة للكيروجين. التمبريتشر هنا is the single most important factor in the thermal maturation. أهم عامل في عملية الماتوريشن is the temperature الذي حصلت في باطن الأرض. Okay. As we said here, when the depth increase, the temperature has been increasing, and then starting the maturation of that heavy oil to oil and gas, and then light oil and gas, and then mostly gas, and we reach the gas only. The oil and gas windows, most pressure that affects rocks is due to the weight of the overlying أو ما يسموها overburden rocks, and this can be by pressure called the overburden. هذه الروكس نفسها بتعمل لك generation لضغط اسمه the overburden pressure. This overburden is a function of depth علاقة بالعمق and increase 1 pound per square inch. 1 pound per inch تربيع. That's mean PSI. Okay. ويزداد معانا 1 PSI معناته هنا for each feet of that depth. كل 1 feet من هذا العمق بيزداد معانا 1 PSI. It shows clearly at what temperature oil generation peaks. Just like here we have the hydrocarbons per percent, and we have the temperature in Celsius. So as the temperature has been increased, the oil and gas windows, just like in this, we have principal zone of oil formation لأن درجة الحرارة لا زالت ضعيفة مش كبيرة, and we have the gas formation here لأن درجة الحرارة زادت بشكل عالي. Oil generation diminishes above 180 degrees Celsius. The oil formation here, the temperature required to produce crude oil occur between 5,000 to 20,000 feet of that depth. لاحظ انه كل ما زاد العمق حق الطبقة كل ما زاد درجة الحرارة كل ما تولد liquids and then converted to what? Gaseous status. Hydrogen formation and the generative potential of source rock. Here are definitions and some alternative information about the hydrogen. Hydrogen has no unique molecular structure and can only be defined in terms of bulk, elemental composition, and average molecular distribution. So the hydrogen itself is often described as mixtures of amorphous organic matter and materials. So the hydrogen quality is mainly functions of the hydrogen content to the hydrogen with high hydrogen to carbon ratios. What is that hydrogen? There are some information here called about the hydrogen, just like its processor to the oil and gas, also insoluble in the organic solvent, يعني ما يذوبش في المحاليل العضوية. It's a complex mixture of high molecular weight organic materials. The bulk composition determined by source and environment. التركيب الصخري لهذا الهيدروجين نفسه the bulk أو الحجمي determined by its source and environment, يعني المصدر الذي هو تولد منه أصلا أو البيئة الذي بدأ يتحول فيها أو يتكون فيها. General composition may be described by its formula, which is discussed below. Here in this table we have the hydrogen type, الأنواع الموجودة للهيدروجين and their occurrence تواجدها and the كيميائية هذه الهيدروجين. Just like the number 1 we have the type number 1 هذا the deposition setting. That's mean where it doesn't sit, can be in the lakes or lagoons, and then primary biotic input ايش المدخلات حقه الذي موجودة في هذا الهيدروجين, green algae طحالب خضراء وغيره. Here and have some ratios related to that hydrogen. It can be the hydrocarbon to carbon, oxygen to carbon, and the sulfur to carbon. And this is for lecture 4. We have completed, and let's move just only to lecture 5 and lecture 5 it's only 17 slides, and lecture 6 is only 20 slides, so I merged them to one 5, starting with the petroleum system. So the reservoir geology, here is a picture just to illustrate the petroleum or reservoir geology by the earth crust, and mention for a specific place for that reservoir to be just like this. Have here an anticline in this place, and the accumulation of that oil and petroleum, which is the oil and gas and water in this reservoir, which has been sealed by structure trap. The reservoir rock, what is that reservoir and how it does it develop over time? معروف معانا إنه الريزرفوار is a subsurface volume، عبارة عن حجم تحت الأرض، مكان أو خزان على ما بيقولون. It's not خزان مثل الخزان الأرضي الذي موجود معنا في البيت، بس عبارة عن صخور. هذه الصخور it has properties مثل to be porous and permeable rock that both has storage capacity and the ability to allow fluid and to flow through it. When we say it has a storage capacity, that means it has a porosity, also the ability to allow fluids to flow through it. That means the rock has a property of what? Permeability. So there are two types of the reservoir. We have here the carbonate reservoir, just like the limestone, dolomite, and etc. And we have the sandstone reservoir, and we discussed this in the introduction to petroleum engineering. What are the sandstones reservoir? Just like sand, silt, clays, and etc. Physical characteristics of a reservoir. When we say the physical characteristics of a reservoir include the original deposition and the subsequent change, the type of the reservoir, sandstone يعني يكون sandstone أو carbonate، العمق حق المكمن نفسه، the area, thickness, the porosity, permeability, capillary pressure of that reservoir. Carrier bits, which they call sometimes the reservoir itself. The oil is less dense than the water. لذلك تلاحظ الأويل it's what is sink above the the water. Carrier bits here are the rock layers that allow the fluid to pass through them. مثل كذا ليش الساندستون. If petroleum stays buried, it can become both measure and then it can be converted to to gas. A good reservoir دائما يقول لك إنه المكامن الجيدة is تكون فيها porosity أو مسامات عالية وتكون نفاذة. That means these pores are connected together so that its fluid can be produced which removed from those holes. The reservoir rock has two main properties, which is the porosity and the permeability. Just like to be in the sandstone and that limestone. Let's here just say about the porosity here. If we have a rock has a grain volume here and there's pores inside it. هذه مثلا البورس inside it. So a good reservoir can be when the pores are connected together to retain or ممكن remove high contains oil of that petroleum. So the production can be high, and they called it a good reservoir. So the reservoir and the reservoir, it's a porous and permeable lithological unit or set of units. Just like to be here. لاحظ المسامية هنا أو الريزرفوار نفسه عندما يكون here in the sandstone تكون نسبة المسامية والنفاذية عالية جدا. It can be reached to 60%. The carbonate, which is limestone and dolomite, can be related to 39 لأنه المسامات نفسها بتكون أقل. Also the connection between these pores will be less. The fracture rocks or of other types, and when we say the fracture rocks, we mean here just like the basement rocks and the limestone, dolomite, rocks. These will be only percent of that reservoir. So the reservoir rock is that kind of rock which can hold the hydrocarbons. As the percent is high, that means the holding the hydrocarbons will be high. The reservoir rock, just like the dolomite, and when you know this dolomite is just like one type of the limestone rocks, but the limestone has here CO3. The dolomite can be formed by inserting one atom of magnesium to this formula to forming that dolomite. So one of these, the dolomite has an example of important reservoir. Okay, what types, and sometimes they formed just like 2BC rocks. The reservoir rocks are to be confirmed through we can take samples of this reservoir rock by two main methods. These methods, one of these direct methods, it's by coring، انك تاخذ عينة from the reservoir by the عن طريق الحفرة وكذا تاخذ منها عينة أو ما يسموه الcoring. Also the indirect method, it's by the well logging. You are inserting a well logs to the well, and these well logs can be gain the information about these reservoir properties, the reservoir rock properties. So there are direct methods انك تحسس هذه العينة وتأخذ منها الخصائص البروسيتي والبرميابيتي والسيتريشن وغيره. وفي الاندايركت ميثود الذي هي الويل لوجينج الذي ان شاء الله بدرسه في سمستر 6. Reservoir porosity and permeability. There are two fundamental physical properties that a good reservoir must have. Porosity, which is the first one, porosity or sufficient void space, they call this sometimes the void space, to contain significant petroleum. And also the permeability, the ability of that rocks to flow that fluids through these voids or pores. There is an equation for this porosity, which is the total volume of that rock to the volume of that void space. عفوا في خطأ هنا في القانون. القانون بيقول إنه البورستي بتساوي the phi pore على الفي bulk, and we noticed here إنه عكسه في القانون. It can be by from the reference that I took. So it's حجم الفراغ المسامي الذي هو مكتوب تحت per the bulk volume of that rock يطلع لك the porosity of that rock. So the pore permeability here when can be exist when the fine grains of that reservoir are connected to each other, so the fluids can't be moved through those rock. وهنا بيقول لك pore permeability and there are poorly sorted. تكون في معك fine grains كبيرة وتكون معك grains كبيرة وفي معك grains small. So the poorly sorted can affect on on the permeability. كل ما كان الsorting ضعيف كل ما كان permeability ضعيفة. Porosity types, we have talking about the porosity type, which is the primary porosity, and this which comes first or primary through the sedimentation process or the time of the deposition. وفي معنا secondary porosity الذي تتولد post ما بعد عملية الترسيب, just like the porosity result from the groundwater dissolution أو عملية اسمها recrystallization إعادة التبلور, and the fracturing أو ما يسموه fracturing حق الريزرفوار نفسه لما يحصل تصدع أو هذا بيولد لك something called secondary porosity. The types of that porosity, we have the total porosity here, which is the porosity of the interconnected pores plus the unconnected pores, but the effective porosity is related to only the interconnected pore volume or pore for inside that reservoir. So if we said here we have here the pore space, and we have also here القانون على فكرة معكوس، لابد ما ترجع هذه وهذه هنا، لأنه الفوليوم اوف ذا void base معناته ايش؟ على ايش؟ الفي بور على الفي بالك. لو كان مثلا الفي بور معانا 10، لو قلنا عليها قسمة مثلا حجم الصخرة كامل كان 20، so the porosity is what 50%. حاول تقلب ليش القانون عدله. So if we said here the interconnect، لاحظ هنا we have here in this slide the interconnected bores just like to be these areas and this area. لاحظ معانا هنا something called the isolated or non-effective what porosity. So the total porosity can be what and the connected one. لاحظ هنا مثلا البورosity هنا is what is the connected pores through this area. Okay, it can be just like 29%, which is the effective one, and the non-effective, it can be inside this rock there is some porosity here, but it's not what connected. They called it the non-effective effective one, which just composed of 3% porosity. So the total porosity here is the sum of the non-effective and the effective one. Permeability, the recovery of hydrocarbons for this from the reservoir is an important process in petroleum engineering, and estimating the permeability can aid in determining how much hydrocarbon can be produced from the reservoir. يعني إذا عرفنا مقدار permeability and the porosity and saturation ممكن إنك تطلع، حسبتوا حاجة اسمها كان الستويب، درسنا في سمستر 1، حسبنا كم مقدار الأويل الذي ممكن نطلعه من الريزرفوار. So the permeability is a measure of the ability of the rock to transmit those fluids, and the permeability can be measured by a unit called Darcy. 1 Darcy can be 1000 milli Darcy. Permeability and the grain size and the shape itself. لاحظ معي في الصورة هذه the large round grains of these areas and can be given for us some permeability or some void space through these rocks. And there is also the second type of these grains, they called it the large flat، وهذا بيعطينا مجالات بعض الأحيان أقل من مجالات لما تكون ليش الحبوبات fine grains. very small angular grains. لاحظ في الشكل الأول كانت المسامية هنا 1500 ملي دارسي، عندما يكون large flat grains بتكون المسامير معنا 800 ملي دارسي. when these grains to be flatted more، that's mean بتغلق على المسامات بشكل أكبر، بحيث تكون المسامير حق الطبقة النفاذية حق الطبقات less than the normal thing. so ما بيطلع لنا فقط الله 50 ملي دارسي. the very small angular grains، لاحظ هنا الجرينز ايش angular، والانجولار معناته ليست rounded، وهذه بتغلق دائما على المسامات في المنطقة نفسها. so the grains itself can be affected on the porosity، مع بيكون معنا البرميابيليتي، عفوا الجرين نفسها بتأثر على البرميابيليتي، ما بتكون معنا البرميابيليتي إلا 15 ملي دارسي. and this is called a bore reservoir. so the porosity is not depend on the grain size، بينما البرميابيليتي بتأثر أو تعتمد على الإيش الجرين size. fluid distribution in that reservoir according to the gravity of these fluids. the natural gas which is the least dense of these fluids، معناته على حسب الإيش الكثافة بتتجمع هذه أو تتوزع هذه الفلويدز في الوين في الريزرفوار. So the natural gas will be in the above, and the oil would be in the middle between the gas and the water. The water, which is high, the denser than the two fluids, so it's what is sink in the bottom of that reservoir. Capillary pressure. Capillary pressure, and it is one. They called it one property of the reservoir, which is the fourth one of the fourth property of the reservoir rocks. So the reservoir rocks are composed of varying sizes of grains and pores and capillaries also. These capillaries, that means the channels between the grains which connected the pores together, sometimes called the pore throats. So here, as the size of that pores and channels decrease, كل ما قلت حجم المسامات والقنوات نفسها, the surface tension of these fluids in the rocks is dead. So when there are several fluids in the rocks, each fluid has a different surface tension. So and adhesion نفسه ما يسموها خاصية الالتصاق في هذا الريزرفوار rock that cause a pressure variation between these rocks. بيحصل عندنا اختلاف في الضغوط في لهذه المواعي في هذا الصخرة نفسها. So this pressure is called the capillary pressure, يسموه الضغط الشعري أو الخاصية الشعرية للسوائل أو غيره. عندما يكون في معنا two fluids اثنين مواعي مرتبطين مع بعضهم in the same rocks, بيتولد عندنا capillary pressure, and is often sufficient to prevent the fluid of one fluid in the presence of another fluid. Physical characteristics of reservoir. One of the physical characteristics also of the reservoir is the depth of that reservoir itself. The physical characteristics of the reservoir are greatly affected by its depth. تلاحظ عندك لو ما يزيد الدبث حق الريزرفوار نفسه, الفيزيكال property of reservoir يكون مثلا more compacted or more sedimented, that means بيكون less porosity and this permeability. So we have here shallow reservoirs creating by something called folding of that relatively thick, moderately compacted reservoir rock, which with accumulation of something called anticline or some traps. We have the deep reservoir. This just typically created by severe faulting. يكون في عدة فوالق. عدة الفوالق هذه لأن الريزرفوار ايش بيتعمق أكثر. Area and the area of the reservoir. لاحظ معانا في معادلة الستويب نفسها. One of the main parameters is the area and the thickness of that reservoir. فلو ما تختلف الاريا and the thickness of the reservoir بتلاحظ معك حتى أن the quantity of the oil in the reservoir is what is affected. So the greater area and thickness of the reservoir, that means the greater potential of large hydrocarbons of oil and gas. traps, والذي هي المصاعد التي موجودة معنا في باطن الأرض. So how to find oil source rock, reservoir rocks, and the structure traps. Traps in the earth can be formed by structural or stratigraphic traps. One of these structural traps, just like the anticline traps here, and also there are other types, comes from the reservoir rock to the reservoir rock, and there is an oil reservoir here, can be trapped by something called anticline. The traps, if nothing stops the oil from rising, إذا ما فيش أي حاجة عاقت الأويل هذا إنه يطلع على السطح، إنه يطلع من الريزرفوار، معناته بيوصل لوين إلى السطح and forms in the lakes just like this. So the traps can be any rock that don't allow the fluids to pass through them. ولا بد ما تكون هذه ليش الترابس impermeable rock، يعني صخور غير نفاذة. or just like to be faults, and faults in the rocks can trap what? That petroleum. Natural traps keeps the oil and gas from oozing out of that surface, just like this. We have here natural traps إنه إن الأويل ما بيحصل معنا إلا وين للsurface, or just like to be escaped to the surface. So the trap is the stratigraphic or structural feature of the earth that ensure the juxtaposition of the reservoir, and then seal that such that hydrocarbons remain trapped in the subsurface, rather than بدل ما إيش escaping or being lost in the another or adjacent layers. The subsurface obstacle here to flow of that petroleum to the earth surface. Type of traps we have the structural traps. Here the traps can be produced by the deformation of bits. وهذا اللي يميزها إنه حصل لها deformation of bits. It can be by either folding or faulting. Also we have something called the stratigraphic traps, and the traps are formed by the change in the nature of the rocks of self. هذا ما يميز هذا النوع. And also we have combination traps الذي يكون فيها structural and stratigraphic traps in the same trap, called what? A combination trap. The fourth one of these traps will let you first know about it. It's the hydrodynamic traps. These traps is due to what? The water flowing through the reservoir and holding the oil in places where it wouldn't otherwise be trapped. So this picture can be illustrated the generation, migration, and trapping of that hydrocarbon. So there is the source rock, where is the place of that oil kitchen, which is formed here, and then move to the reservoir rock to carry it throughout the reservoir until it comes to the accumulation here in this area. So, and then trapped by a structure or structural trap called a fault through these area, which is the shear rocks. Structural traps can be just like to be anticline or a fault trap. لاحظ هنا حصل معانا deformation للروك نفس strata within the earth crust. Also the fault traps معناته يكون في معانا فالك في الأرض نفسها، حصل إنه the strata which is above this area كانت في يوم من الأيام ملتصقة مع بعضها البعض من above إيش strata، فحصل فالك ما بين الأرض يكون just like this. فتلاقي الطبقات التي موجودة مثلا الذي في هذه المنطقة هي نفسها كانت الطبقات التي موجودة في إيش هذه المنطقة. So the faulting of these stratigraphic rocks occurs as a result of vertical and horizontal stresses، أو يسموها اجهادات أفقية وعمودية في باطن الأرض، مما أدت إلى هذه الإيش الfaulting. The fault trap is formed when the faulted formation are tilted toward the vertical. فلاحظ معي مثلا يكون معنا the reservoir rocks or a sandstone area or bits. Above it there is a shear rocks in this area, so when there is a migration of oil from this area until it becomes into this area, it has been trapped in this place and can't be migrated to the surface. Just like this we have the structural traps. Here the main one, which is the anticlinal trap, and also there is unconformity trap by that one kind of that stratigraphic، انه حصل هنا عدم توافق للطبقة نفسها. فلاحظ معي في هذه الطبقات كلها there is a green bed here, but in this place there is no green فهذا حصل يسموه عدم توافق الطبقات. هذه الطبقات تواجدت في هذه المناطق هنا وهنا and اختفت في هذه المنطقة، وهذا يسموه unconformity trap. tilted one تكون الطبقات مثلا نفسها ماشية مع نفس اللاين، بتجي لك مثلا طبقة واحدة هذه it's tilted fold block trap، يعني اتجاهها عكس اتجاه الطبقات الأخرى. Structure trap, the main one of the three main types, which is the important one, which is the salt dome traps. And also we have here the fractured basement, which has no porosity or permeability, and there's the fold trap or ما يسموها the anticliner. Common traps types, just like this, two anticline traps in the same area. We have one main trap here, which is the anticline. Also we have here the faults in this area. Okay, we have here just like to be a mud volcano. لو لاحظت هنا في المنطقة بيكون معانا there are many traps in this area, just like to be anticline, also the fault, also the mud volcano of that area. Here there is a main fault of this area which shows that the top of the lower مثلا هذه hack berry وهذه the top of lower hack berry. One times at كان في زمن من الأزمان تلاحظ المنطقتين هذه كانت مع بعضها، بس حصل الفالق هذا الذي make these layers lower and makes these as in the above، وبعدين يحصل sedimentation فوق هذه الطبقة. So if there is oil in this area, it can comes to here and then trapped in this area يحصل كريزورفوار روكس أو ريزورفوار أو الريزورفوار يعني. Stratigraphic traps وهذه formed as a result of difference or variations between or within the stratified rock layers, creating by a change or loss of that permeability from one area to the other. Just like these stratigraphies يسموها bench out، just like تكون هكذا مثل العدسة أو مش تكون يسموها sometimes just like the lenses. Also we have something called the pre and post conformity. حصل معنا عدم توافق في الطبقات هذه مما أدى إلى تواجد الأويل في المنطقة هذه، تواجد الأويل في المنطقة الأخرى. Pinch out or laterally graded هذا it comes by or created by lateral differential deposition when the environmental deposition changes up deep. تلاحظ مثلا معانا الطبقات كانت بتمشي مثلا على هذا الأساس، okay, and then حصل يسموه graded lateral graded deep، معناته انه الطبقات حصلت انها مالت في هذه المنطقة. فلاحظ طبقة الأويل حصل ان الأويل تجمع and trapped in this area ما بين the lower of this area and the top of that area, so it can be يسموها pinch out trap. angular unconformity يكون مثلا معنا eroded incline، كان في طية محدبة المفروض انها كانت تكتمل بهذا الشكل، so تآكلت هذه الطبقة في هذه المنطقة تآكلت and then there is a formation has been sitting and dipping in this من فوق الانتكلاين، في سموها طية محدبة متآكلة. also eroded just like this eroded incline كانت في زمن من الأزمان ممكن تتكون بهذا الشكل and then this formation has been deposited above this incline. فلاحظ هنا في هذه الصورة التي موجودة في الجبال angular conformity هنا something called الذي هو عدم التوافق الزاوي. لاحظ الطبقات كانت في هذه المنطقة على هذا الشكل، okay, and there is unconformity حصل عدم توافق في هذه الطبقات to be just like this، يعني يكون بدأ الترسيب لهذه الطبقات بشكل معين and then حصل عدم توافق وحصل ايش تآكل لهذه المنطقة and then started to what deposited بطريقة ايش أخرى horizontally. And this is for today. Thank you very much my students. This lecture was about review of chapter 4, and also we have studied chapter 5 and 6. The next lecture inshallah, the next video that I will do it بيكون على chapter 7 and 9 and 7 and 8 and 9. بيكون في مقطع واحد إن شاء الله بنزله في الأسبوع القادم. لكم مني أجمل تحية واعذرونا على تأخير هذا الفيديو. but I حاولت أن بشكل مستطاع أو بقدر المستطاع أن أنا أنزل مقطع يكون الوضوح فيه كبير، وأيضا الشرح فيه عن طريق القلم حق التلفون ليسهل علي وعليكم وصول المعلومة. وشكرا جزيلا، ونلقاكم إن شاء الله في